What if I told you that right now, somewhere in the darkness between Mars and Jupiter, a visitor from another star system is tumbling silently through space, and it might hold the key to understanding whether we're truly alone in the universe? This isn't science fiction. This is the story of 3I/Atlas, an interstellar wanderer that slipped into our solar system like a whisper from the cosmic deep. But here's the twist. Scientists tried to understand it for years, and what they discovered challenges everything we thought we knew about visitors from other stars. In the next 3 hours, you'll drift into peaceful sleep while uncovering the hidden truths of this mysterious traveler. This isn't just science, it's your story, written across the fabric of the universe, connecting you to the vast tapestry of space and time that surrounds us all. Tonight we'll journey together through the gentle mysteries of the cosmos, where each revelation brings not alarm, but wonder, where each scientific discovery becomes a lullaby sung by the stars themselves. If you love journeys like this, like this video, subscribe, and comment your country and what time you're listening. Let's create a global community of cosmic dreamers united under the same starlit sky. Picture yourself on a quiet hilltop observatory on a September evening in 2019. The air is crisp and still, carrying the scent of autumn leaves. Above you, the Milky Way stretches across the darkness like a river of light, and somewhere among those distant stars, something extraordinary is about to reveal itself to human eyes for the very first time. Dr. Gennady Borisov, a Crimean astronomer whose gentle passion for the night sky had led him to discover comets before, was methodically scanning the heavens through his modest telescope. The rhythm of his observations was meditative, almost like a cosmic prayer. Point, focus, capture, analyze. Point, focus, capture, analyze. But on this particular night, something broke the pattern. There, moving against the stellar background with an urgency that seemed to whisper secrets from the depths of space, was a fuzzy, comet-like object. At first glance, it appeared unremarkable, just another icy wanderer from the outer reaches of our solar system. But as Dr. Borisov tracked its movement over the following nights, something magnificent and impossible began to emerge from the data. The object's trajectory was wrong. Not wrong in the sense of being an error, but wrong in the most beautiful, mind-expanding way possible. This visitor wasn't following the gravitational rules that govern objects born in our solar system. Instead, it was moving on what astronomers call a hyperbolic orbit, a path so energetic, so decisively swift, that it could only mean one thing. This traveler had come from another star. Imagine the profound silence that must have settled over Dr. Borisov as this realization dawned. Here was physical proof of something that had tantalized humanity for generations, a piece of another star system carrying within its ancient ice and rock the chemical signatures of alien suns, now gracing our cosmic neighborhood with its presence. The object was designated 2I/Borisov, the I standing for interstellar. Only the second such visitor ever detected by human eyes. But unlike its predecessor, the mysterious ʻOumuamua, this new arrival was clearly a comet, complete with the telltale fuzzy atmosphere called a coma that forms when solar heat begins to vaporize its icy surface. As news of the discovery rippled through the global astronomical community, something beautiful happened. Telescopes around the world turned their attention skyward in a coordinated dance of curiosity. From the volcanic peaks of Hawaii to the clear skies of Chile's Atacama Desert, from space-based observatories to amateur astronomers in their backyard setups, humanity united in wonder to study this messenger from the stars. But here's where our story takes its first gentle twist. As observations poured in from around the globe, scientists realized that 2I/Borisov wasn't just any interstellar visitor. It was, in many ways, remarkably similar to comets born in our own solar system. Its composition, its behavior as it warmed in our sun's light, even the way its tail developed, all of these characteristics suggested something profound about the universality of planetary formation. Yet beneath this familiar behavior lay deeper mysteries. Where had it come from? What star had once warmed its surface? And most intriguingly of all, what could this visitor tell us about the potential for life beyond our solar system? As you settle deeper into your pillow tonight, let your mind drift among the stars, imagining this ancient traveler beginning its journey, perhaps millions of years ago, from a sun whose light we've never seen, carrying with it the chemical fingerprints of worlds beyond our imagination. Let's drift back through time to understand why 2I/Borisov represents such a profound moment in human discovery. Close your eyes and imagine the cosmos as it existed in the minds of scientists just a few decades ago. For most of human history, we believed our solar system was unique, perhaps even singular, in the universe. The 8 planets orbiting our sun, the asteroid belt with its ancient rocky remnants, the icy Kuiper belt objects dancing in the outer darkness, all of this seemed like a cosmic accident, a rare arrangement of matter and energy that might never be repeated elsewhere. But in 1995, a discovery changed everything. Swiss astronomers Michel Mayor and Didier Queloz detected the first planet orbiting a sun-like star beyond our solar system. 51 Pegasi b, as it came to be known, was nothing like the planets in our cosmic neighborhood. It was a gas giant larger than Jupiter, yet it orbited its star closer than Mercury orbits our sun, completing a full year in just 4 Earth days. This discovery was like opening a door to a hidden mansion. Room after room of exoplanets began to reveal themselves. Hot Jupiters with atmospheres of vaporized metal, super-Earths with masses several times our own planet, systems with multiple stars where sunsets paint the sky in alien colors. Today we know of thousands of exoplanets, and statistical analyses suggest that virtually every star in our galaxy hosts at least one world. The Milky Way contains over 100 billion stars, which means there could be hundreds of billions of planets scattered throughout our cosmic home. But here's the gentle revelation that 2I/Borisov brought to light. If the galaxy is teeming with planetary systems, then space itself must be filled with the debris of their formation, chunks of rock and ice ejected during the chaotic early years when planets were still settling into their orbits. Think of it like leaves scattered by an autumn wind. During the formation of every planetary system, gravitational interactions fling countless objects into interstellar space. These cosmic refugees carry with them the chemical signatures of their birth systems, becoming inadvertent ambassadors traveling between the stars. The discovery of 2I/Borisov confirmed what scientists had long suspected but never been able to prove. Interstellar space is not empty. It's a vast ocean filled with the wandering remnants of planetary formation, each object a potential time capsule, preserving the conditions that existed around distant suns billions of years ago. As astronomers studied 2I/Borisov more closely, they realized they were looking at something extraordinary, not just a visitor from another star, but a Rosetta Stone that could help decode the processes of planetary formation throughout the galaxy. Its composition could reveal whether the building blocks of planets are universal, whether the same materials that formed Earth and Mars and Jupiter might also be scattered throughout countless other systems. But the most profound realization was yet to come. If objects like 2I/Borisov are common, if they represent just the tip of an iceberg of interstellar wanderers, then our solar system is not an isolated island. We are part of a vast, interconnected web of matter and energy that spans the entire galaxy. Every breath you take contains atoms that were once part of distant stars. Every drop of water you drink may have formed in the outer reaches of our solar system, or perhaps even beyond. And now, for the first time in human history, we could study a visitor that had once orbited another sun, bringing with it the chemical memories of alien worlds. As you drift towards sleep, imagine yourself not as a resident of Earth, but as a citizen of the galaxy, connected through physics and chemistry to every star, every planet, every grain of cosmic dust in the Milky Way's spiral arms. Now comes a twist in our cosmic tale that reveals something unexpected about the nature of discovery itself. As ʻOumuamua continued its journey through our solar system, astronomers around the world worked frantically to gather as much information as possible before it disappeared forever into the darkness between stars. But there was a problem. Despite being the most studied interstellar object in history, ʻOumuamua was stubbornly refusing to give up all its secrets easily. You see, when sunlight hits a comet's surface, it causes the ice to sublimate, to transform directly from solid to gas, creating the beautiful glowing coma and tail that make comets such spectacular sights. Scientists can analyze the light reflected and emitted by these gases to determine the comet's chemical composition, like reading a cosmic fingerprint. With ʻOumuamua, however, something puzzling emerged from the data. While the comet's overall behavior was remarkably similar to comets from our own solar system, there were subtle differences that suggested something profound about the nature of planetary formation across the galaxy. The water vapor streaming from ʻOumuamua had an unusual isotopic signature. The ratio of heavy water to normal water was different from what we typically see in solar system comets. This might seem like a minor technical detail, but it's actually a key to understanding the temperature and conditions that existed in the outer regions of ʻOumuamua/Borisov's birth system. Even more intriguingly, spectroscopic analysis revealed that ʻOumuamua/Borisov contained an unexpectedly high concentration of carbon monoxide, much higher than most comets from our outer solar system. This suggested that it had formed in a region that was even colder than the outer reaches of our own cosmic neighborhood. But here's where the story takes on an almost poetic quality. As scientists worked to understand these differences, they began to realize that ʻOumuamua/Borisov wasn't just a random visitor. It was a messenger carrying information about the diversity of planetary system formation throughout the galaxy. Think about what this means. In our solar system, comets formed in the cold, outer regions preserve a chemical record of the earliest days of planetary formation 4.6 billion years ago. They're like cosmic time capsules, frozen libraries containing the story of how our system came to be. ʻOumuamua/Borisov represents the same kind of time capsule, but from an entirely different star system. By comparing its composition to our own comets, scientists could begin to understand which aspects of planetary formation are universal and which are unique to specific stellar environments. The unexpected twist. The more they studied ʻOumuamua/Borisov, the more they realized that planetary formation might be far more diverse than anyone had imagined. Each star system might develop its own unique chemical signature, its own particular way of assembling planets from the cosmic dust and gas that surrounds young stars. This diversity isn't a flaw in our understanding. It's a beautiful feature of how the universe works. Just as snowflakes form according to universal physical laws, but each one is unique, planetary systems throughout the galaxy might follow the same basic rules while creating an endless variety of worlds. And here's the most beautiful part of this realization. If planetary systems are this diverse, if the chemistry and physics of world formation can take so many different paths, then the potential for life throughout the galaxy might be far richer and more varied than we've ever dared to imagine. As ʻOumuamua/Borisov continued its journey away from our sun, growing fainter each day as it returned to the cold darkness of interstellar space, it left behind something precious. Proof that we live in a galaxy where diversity and creativity are written into the very laws of physics. Tonight, as you close your eyes, let your mind wander among the countless star systems scattered throughout the Milky Way, each one a unique experiment in world building, each one potentially harboring its own forms of life, beauty, and wonder. There's something profoundly intimate about ʻOumuamua/Borisov's visit that connects directly to your own existence in ways that might surprise you. As you lie here, breathing slowly and deeply, consider this. The atoms in your body, the carbon in your muscles, the oxygen in your lungs, the calcium in your bones, were all forged in the nuclear furnaces of ancient stars. But ʻOumuamua/Borisov's journey reveals something even more remarkable. The same stellar processes that created the elements in your body also created the materials that went into forming this interstellar visitor. In a very real sense, you and this cosmic wanderer are siblings born from the same stellar nurseries, shaped by the same universal forces. Let your mind drift back to the early days of our galaxy, billions of years ago, when the first generation of stars was beginning to die. These massive suns, perhaps 100 times more massive than our current sun, lived fast and died young, exploding as supernovae that scattered heavy elements throughout space. Picture these cosmic explosions as acts of generosity, stellar beings giving their lives to seed the galaxy with the ingredients needed for planets, for oceans, for life itself. The shock waves from these explosions compressed nearby clouds of gas and dust, triggering the formation of new stars and planetary systems. Some of these heavy elements, forged in stellar hearts and scattered by stellar deaths, eventually became part of the disk of material that surrounded our young sun 4.6 billion years ago. Gradually, through countless collisions and gravitational attractions, this material assembled into the planets and moons and asteroids that make up our solar system today. But other elements, created in the same stellar furnaces, followed different paths. They became part of the material that formed planetary systems around other stars, perhaps in distant regions of the galaxy, where the chemical composition was slightly different, where the stellar nurseries operated under subtly different conditions. ʻOumuamua/Borisov represents one possible outcome of this cosmic recycling process. Its atoms were born in stellar deaths, just like yours, but they followed a different journey through space and time, where your atoms settled into orbit around our sun and eventually became part of a living, thinking being. ʻOumuamua/Borisov's atoms became part of a wandering archive, preserving the chemical memory of an alien star system. This connection goes deeper than mere chemistry. Both you and ʻOumuamua/Borisov are participants in the galaxy's ongoing conversation with itself. Your thoughts and dreams and midnight wanderings are part of how the universe comes to understand its own nature. ʻOumuamua/Borisov, carrying information from one star system to another, is part of how different regions of the galaxy share their stories with each other. In a sense, every time you look up at the night sky and feel that sense of connection to something larger than yourself, you're participating in the same cosmic dialogue that ʻOumuamua/Borisov represents. You're a conscious expression of the universe's tendency toward complexity and beauty, just as ʻOumuamua/Borisov is a physical expression of the universe's tendency toward exploration and exchange. Consider this beautiful fact: as you sleep tonight, ʻOumuamua/Borisov is continuing its journey into the depths of interstellar space, carrying with it the gravitational memory of its encounter with our sun. In some infinitesimally small way, its trajectory has been altered by its passage through our solar system, which means it now carries a tiny signature of our cosmic neighborhood with it on its journey to the stars. Similarly, our solar system has been infinitesimally altered by ʻOumuamua/Borisov's visit. The gravitational dance between our Sun and this interstellar visitor has left subtle changes in the orbital dynamics of our system, changes so small they'll never be measurable, but real nonetheless. This is how the universe works, through countless tiny interactions, each one insignificant on its own, but collectively weaving the fabric of space and time into increasingly complex and beautiful patterns. You are part of this process, both as an observer who can contemplate these mysteries and as a participant whose very existence changes the universe simply by being in it. As sleep begins to embrace you, let yourself feel the profound connection between your warm, breathing body and the cold, distant traveler that graced our solar system with its presence. You are both children of the same cosmic story, expressions of the same creative forces that have been shaping the galaxy for billions of years. In your dreams tonight, you might find yourself traveling alongside two I/Borisov, witnessing the slow dance of stars as they wheel through their ancient patterns, feeling yourself to be exactly where you belong, at home in the vast, beautiful, endlessly creative universe. Now, as we settle deeper into our cosmic story, let's return to that central question that opened our journey. What's the worst-case scenario when it comes to two I/Atlas and visitors like two I/Borisov? But perhaps we need to reframe what we mean by worst case. The gentle truth is that the real worst case isn't some catastrophic collision or alien invasion from the pages of science fiction. The real worst case would be never knowing these visitors exist at all, living our entire existence as a species without ever realizing that we're part of a vast galactic community of worlds, connected by the slow dance of matter and energy across interstellar space. Before 2017, when ʻOumuamua first revealed the reality of interstellar visitors, humanity had spent its entire history looking up at the night sky without knowing that space itself was filled with wandering ambassadors from other star systems. We were like children who had never heard of other countries, unaware that beyond our familiar neighborhood lay an entire world of different cultures and landscapes and possibilities. The discovery of two I/Borisov confirmed that ʻOumuamua wasn't a once-in-a-lifetime anomaly. These interstellar visitors are part of the normal fabric of our galaxy, as natural and inevitable as migrating birds or ocean currents. At any given moment, there are likely dozens or even hundreds of such objects passing through our solar system, most of them too small or too distant to detect with our current technology. This realization brings us to a beautiful paradox. The more we learn about these visitors, the more we realize how much we still don't know. Each new discovery reveals new questions, new mysteries that beckon us toward deeper understanding. Consider the object designated 3I/Atlas mentioned in our title, a potential third interstellar visitor that astronomers continue to study and debate. The designation itself represents the cutting edge of our cosmic awareness, the growing recognition that our solar system exists not in isolation, but as part of a vast network of gravitational relationships that extend throughout the galaxy. As you breathe slowly and steadily, imagine the solar system not as a fixed, unchanging arrangement of planets and moons, but as a dynamic, living system in constant communication with the galaxy around it. Every day, cosmic dust from other star systems settles into our atmosphere. Every year, gravitational perturbations from passing stars subtly alter the orbits of distant comets in our outer solar system. We live in a universe where boundaries are fluid, where the edge of our solar system blends seamlessly into the interstellar medium, where the very atoms in our bodies connect us to stars that existed billions of years before our sun was born. The worst-case scenario isn't that these visitors might somehow threaten us, it's that we might not pay attention to the profound gift they represent. Each interstellar object is a natural space probe carrying information about conditions around other stars, offering us insights into how planetary systems form and evolve throughout the galaxy. But here's the truly remarkable thing: we're living through the very first chapter of this story. You are part of the first generation of humans to know with certainty that we receive regular visits from other star systems. Your children and grandchildren will grow up in a world where interstellar archaeology, the study of visitors from other star systems, is the established scientific field. They'll have access to data from dozens or hundreds of interstellar objects, allowing them to piece together a comprehensive picture of how planetary formation works throughout our galactic neighborhood. They might even develop the technology to intercept and study these visitors up close, or to send our own emissaries to other star systems. The gentle irony is that what we call the worst-case scenario in our title is actually the opening chapter of what might be the greatest adventure in human history. Our gradual recognition that we're citizens not just of Earth, not just of the solar system, but of the entire galaxy. As you drift deeper into peaceful sleep, let yourself feel the privilege of living during this moment of cosmic awakening, when humanity is first beginning to understand its true place in the vast, interconnected web of matter and energy that we call home. There's something about interstellar visitors like ʻOumuamua/Borisov that touches on what might be the most impossible phenomenon in the entire universe. And yet it's happening all around us all the time, in the most natural and beautiful way imaginable. Let yourself sink deeper into your pillow as we explore this gentle mystery. The impossible thing isn't that these objects can travel between star systems. Space is vast, but gravity and orbital mechanics are well understood. The truly impossible thing is that we can recognize them at all. Think about what has to align perfectly for us to detect and understand an interstellar visitor. First, the object has to pass close enough to our sun to be warmed and brightened so that our telescopes can see it against the cosmic background. Then, it has to maintain that visibility long enough for astronomers to calculate its orbit and realize that it's following a hyperbolic trajectory, the mathematical signature of an interstellar origin. But even more remarkably, it has to arrive at exactly the right moment in human history, after we've developed the technology to detect such objects, but also after we've developed the theoretical framework to understand what we're seeing. If ʻOumuamua/Borisov had visited our solar system just 200 years ago, it would have passed through completely unnoticed. If it had arrived even 50 years ago, we might have detected it, but dismissed it as just another comet, lacking the computational tools to recognize its true interstellar nature. The timing seems almost impossibly perfect, as if the universe has been waiting for us to develop the eyes to see and the minds to understand before revealing these cosmic secrets. But perhaps that's not so impossible after all. Perhaps what we're witnessing is part of a natural progression that occurs around many stars throughout the galaxy, the gradual awakening of intelligence to its cosmic context, the moment when a young technological civilization first realizes that it's part of a much larger community of worlds. Consider this beautiful possibility. Maybe every star system that develops intelligent life goes through this same moment of recognition. Maybe right now, around a star dozens of light years away, astronomers are making their own first detections of interstellar visitors, experiencing their own moment of cosmic awakening. And maybe, if we could somehow communicate across those vast distances, we'd discover that intelligence itself is the universe's way of coming to understand its own nature, that consciousness isn't an accident or an anomaly, but an inevitable expression of the same creative forces that form galaxies and ignite stars. The study of ʻOumuamua/Borisov revealed something profound about the interconnectedness of all things. Its chemical composition suggests that the basic building blocks of planetary systems might be surprisingly uniform throughout the galaxy. Water, carbon monoxide, simple organic compounds. The same materials that make life possible on Earth appear to be scattered throughout interstellar space. This universality hints at something extraordinary. The possibility that life itself might be not rare and precious, but abundant and varied, expressing itself in countless forms throughout the galaxy. Every star system might be conducting its own experiment in complexity and consciousness, contributing its own unique perspective to the universe's ongoing conversation with itself. As you breathe slowly in the darkness, imagine yourself as part of this vast cosmic awakening. Your thoughts and dreams and midnight wanderings are expressions of the universe's capacity for self-awareness. Your curiosity about these interstellar visitors is part of how the galaxy comes to understand its own structure and beauty. The most impossible phenomenon of all might be consciousness itself, matter, organized in such a way that it can contemplate its own origins, can look up at the night sky and feel wonder, can recognize kinship with a chunk of ice and rock that once orbited an alien sun. And yet here you are, a living expression of this impossibility, drifting peacefully towards sleep while contemplating the cosmic dance that connects all things across space and time. As we reach the heart of our journey together, let's pause to appreciate the profound emotional landscape that opens up when we truly grasp what 2I/Borisov represents. This isn't just a story about astronomy or orbital mechanics. It's a story about recognition, about the moment when we realized we're not alone in our cosmic neighborhood. Close your eyes and imagine standing on that hilltop observatory again, but this time you're not just observing, you're part of the discovery itself. You're feeling that electric moment when the data suddenly resolves into understanding, when the scattered points of light and mathematical calculations suddenly reveal their deeper meaning. This moment of recognition, when Dr. Borisov first realized he was looking at something from another star system, represents one of the most profound emotional experiences available to human consciousness. It's the feeling of boundaries dissolving, of discovering that your neighborhood is far larger and more interesting than you ever imagined. But the emotional impact goes deeper than mere discovery. In 2I/Borisov, we were seeing physical proof of something that poets and philosophers had speculated about for centuries, that we live in a universe where different worlds are connected, where the creative processes that shaped our own solar system have been repeated countless times throughout the galaxy. Every culture in human history has looked up at the stars and wondered whether we're alone. In the gentle, fuzzy glow of 2I/Borisov's coma, we found a partial answer to that ancient question. We are not alone, not because we detected radio signals or alien spacecraft, but because we discovered that the universe itself is alive with exchange, with movement, with the constant circulation of matter and energy between star systems. Think about the emotional journey that 2I/Borisov itself has experienced. Born in the cold outer reaches of an alien star system, it spent perhaps millions of years in the darkness of interstellar space, carrying within its frozen heart the chemical memories of its distant home. Then, after eons of lonely travel, it encountered our sun's gravity and began to warm for the first time in ages. Its surface started to sublimate, creating that beautiful glowing coma that made it visible to our telescopes. In a sense, 2I/Borisov came alive in our solar system, awakening from its interstellar hibernation to briefly shine before returning to the cosmic deep. There's something deeply moving about this cycle of sleeping and awakening, of long journeys through darkness, punctuated by brief moments of warmth and light. It mirrors the rhythm of consciousness itself, the way awareness emerges from the darkness of sleep, experiences the world, and then returns to rest. As astronomers studied 2I/Borisov, they were witnessing what might be called the universe's breathing, the slow circulation of matter between star systems, the way different regions of the galaxy share their creative products with each other across the vast spans of space and time. But perhaps the most emotionally powerful aspect of 2 I/Borisov's visit was what it revealed about time itself. This object had been traveling through space for longer than complex life has existed on Earth. It began its journey when our planet was inhabited only by simple bacteria and algae. It traveled through the darkness as life on Earth slowly evolved into increasingly complex forms: fish, amphibians, reptiles, mammals, and eventually conscious beings capable of recognizing its significance. In a very real sense, too, I/Borisov is older than intelligence itself, at least on our world. It represents a deep time perspective that puts our human concerns into cosmic context. Our entire civilization, everything we've built and discovered and created, has unfolded during just the tiniest fraction of this interstellar visitor's journey. This perspective isn't diminishing, it's elevating. It connects us to the vast scales of cosmic time and space, makes us part of a story that began billions of years ago and will continue billions of years into the future. We are temporary expressions of the universe's creativity, brief flames of consciousness illuminating the darkness for just a moment before passing the torch to future generations. As you settle deeper into sleep, let yourself feel the profound privilege of existing during this cosmic moment, when the universe is waking up to its own interconnectedness through the consciousness of beings like you. Now, as our story begins its gentle transition toward the peaceful depths of night, let's slow our pace and reflect on the deeper implications of what we've discovered together. The frantic excitement of first detection has given way to something more profound, a quiet understanding of our place in the cosmic order. In the months after I/Borisov's discovery, as telescopes around the world tracked its progress through our solar system, something beautiful happened in the scientific community. The initial rush to gather data gradually transformed into a more contemplative process of understanding what this visitor could teach us about the nature of reality itself. You see, the study of interstellar objects like I/Borisov requires a different kind of patience than most astronomical research. These visitors appear briefly in our cosmic neighborhood and then vanish forever into the darkness between stars. There are no second chances, no opportunities to go back and gather more data if something important was missed. This temporal limitation creates a unique form of mindfulness in the scientific process. Every observation becomes precious, every spectrum and photograph an irreplaceable piece of a puzzle that will never be complete. Researchers found themselves savoring the data, turning each measurement over in their minds like a meditation object, looking for subtle patterns that might reveal deeper truths. As I/Borisov grew fainter and more distant, following its hyperbolic trajectory back into interstellar space, the astronomical community gradually shifted from active observation to quiet analysis. The excitement of discovery gave way to the deeper satisfaction of understanding as pattern upon pattern emerged from the accumulated data. One of the most beautiful revelations was how remarkably similar I/Borisov was to comets from our own solar system. Despite having formed around a different star under different conditions, its basic composition and behavior were reassuringly familiar. This suggested something profound about the universality of physical processes throughout the galaxy. Water ice, carbon monoxide, simple organic compounds, the same materials that make life possible on Earth, were present in this visitor from another star system. The universe, it seemed, had a tendency to create similar chemical environments wherever conditions were right, regardless of which particular star provided the heat and light. This uniformity might seem to make the cosmos less exotic, but actually it does something far more profound. It makes it more comprehensible. If the basic chemistry of planetary formation is similar throughout the galaxy, then we can use our own solar system as a guide to understanding how worlds form and evolve around other stars. But perhaps more importantly, this similarity suggests that the physical conditions necessary for life might be far more common than we once believed. If water and organic compounds are scattered throughout interstellar space, hitching rides on objects like ʻOumuamua/Borisov, then the ingredients for biology might be available everywhere that planetary systems form. As you breathe slowly and deeply, let your mind drift among these possibilities. Imagine countless worlds scattered throughout the galaxy, each one receiving its own visitors from interstellar space, each one participating in the same vast circulation of matter and energy that brought ʻOumuamua/Borisov through our solar system. Some of these worlds might be lifeless, their surfaces too hot or too cold to support the delicate chemical processes that we call biology. But others might be oases of complexity and consciousness, home to their own forms of intelligence, their own civilizations looking up at the night sky and wondering about their place in the cosmic order. The gentle truth that emerges from studies like ʻOumuamua/Borisov is that we live in a universe designed for connection. The same physical laws that allow stars to shine also ensure that matter and energy circulate between star systems. The same gravitational forces that hold planets in their orbits also create the complex dynamics that eventually scatter some objects into interstellar space. Nothing in the cosmos exists in isolation. Every star, every planet, every grain of cosmic dust is part of an interconnected web of relationships that spans the entire observable universe. You are part of this web, connected through physics and chemistry to every other conscious being that might exist among the stars. As ʻOumuamua/Borisov continues its eternal journey through the galaxy, it carries with it the gravitational memory of its encounter with our solar system. In some infinitesimal way, it has been changed by its passage through our cosmic neighborhood, just as we have been changed by observing its passage. This is how understanding works in the universe, through countless small interactions, each one adding a tiny increment to the growing complexity of the whole. Your thoughts about these cosmic mysteries, your wonder at the interconnectedness of all things, is part of how the universe comes to understand its own nature. As the night deepens around us and our journey together approaches its quieter phases, let's explore one of the most gentle yet profound aspects of ʻOumuamua/Borisov's story, the way it revealed hidden forces that operate on scales both cosmic and intimate. When astronomers first began tracking ʻOumuamua/Borisov's motion through our solar system, they expected its path to be governed by simple gravitational mechanics. The sun's gravity would bend its trajectory in predictable ways, following equations that Isaac Newton worked out centuries ago and that Einstein refined with his theory of relativity. But as observations accumulated over weeks and months, something subtle and beautiful emerged from the data. ʻOumuamua/Borisov's actual path deviated slightly from the purely gravitational trajectory that mathematics predicted. These deviations were tiny, smaller than the width of a human hair viewed from across a football field, but they were real and consistent. What was causing these minute changes in course? The answer lay in forces so gentle they seemed almost ethereal, the pressure of sunlight itself, and the rocket-like effect of gases vaporizing from the comet's surface as it warmed in our sun's embrace. Imagine ʻOumuamua/Borisov as it approached our inner solar system, its ancient surface beginning to warm for the first time in millions of years. Ice that had been frozen solid since the comet's formation around an alien star began to sublimate, transforming directly from solid to gas in the vacuum of space. These escaping gases created a subtle but persistent thrust, like a spacecraft's thruster, firing continuously at the lowest possible setting. In the deepest part of our night journey together, let's turn our attention to the great cycles that connect ʻOumuamua/Borisov's story to the fundamental rhythms that govern all of existence. There's something profoundly meditative about contemplating these vast patterns, the way they repeat across all scales of space and time, like a cosmic mantra spoken in the language of physics. Consider the grand cycle that brought ʻOumuamua/Borisov to our attention. Birth in the cold outer regions of an alien star system, violent ejection into the darkness of interstellar space, millions of years of patient travel through the cosmic void, brief awakening and transformation in our sun's warming light, and inevitable return to the eternal silence between stars. This pattern, emergence, separation, journey, encounter, renewal, continuation, echoes through every level of reality from the quantum to the cosmic. Your own breath, rising and falling in the peaceful darkness, follows a similar sacred rhythm. Each inhalation draws in the atmosphere that connects you to every other living thing on Earth, every plant and animal that has ever breathed. The oxygen molecules entering your lungs at this very moment may have been exhaled by a whale diving in the deep Pacific, by ancient forests that covered continents millions of years ago, by other human beings across the globe and throughout the long arc of history. Feel the pause at the peak of each breath, that moment of perfect stillness where the atmosphere becomes part of your internal world. During this brief pause, these molecules become intimate participants in your cellular biochemistry, enabling the countless chemical reactions that maintain consciousness and life. Then, in the gentle surrender of exhalation, you return these gases transformed to the planetary atmosphere, enriched with carbon dioxide that plants will eagerly absorb and transform into new growth. This breathing cycle mirrors the larger circulation of matter through our galaxy with stunning precision. Just as your breath connects you to all life on Earth through the shared atmosphere, objects like ʻOumuamua/Borisov connect individual star systems to the vast community of worlds that populate the Milky Way. Each interstellar visitor carries chemical information from its birth system to every other system it encounters, participating in a form of galactic respiration that operates on timescales of millions of years rather than seconds. But the parallel goes deeper than mere circulation of matter. Both your breathing and the galaxy's circulation of interstellar objects serve to distribute essential information and maintain the conditions necessary for complexity and consciousness to arise and flourish. When you breathe, you're not just moving gases in and out of your lungs, you're participating in the planetary scale processes that have regulated Earth's atmosphere and climate for billions of years. The oxygen you inhale was produced by photosynthesis, that miraculous alchemical process by which plants and algae transform the energy of sunlight into chemical bonds while releasing the gas that makes complex life possible. This oxygen didn't appear overnight. It accumulated slowly over billions of years through the patient work of countless generations of photosynthetic organisms, gradually transforming Earth's atmosphere from a reducing environment hostile to complex life into an oxygen-rich medium that supports the incredible diversity of forms we see today. Similarly, when objects like ʻOumuamua/Borisov carry materials from one star system to another, they're participating in galaxy-scale processes that distribute the heavy elements necessary for planet formation throughout cosmic space. These elements, carbon, oxygen, silicon, iron, and dozens of others, were not present when the universe was young. They had to be manufactured in the nuclear furnaces of massive stars and distributed through space by stellar explosions. Without this patient, multi-billion-year process of stellar nucleosynthesis and galactic circulation, star systems like ours, rich in the heavy elements needed to build rocky planets and support life, could never have formed. The atoms in your body are the direct products of this cosmic recycling program, and interstellar visitors like ʻOumuamua/Borisov are the delivery vehicles that keep it operating. The meditative quality of these cycles lies partly in their selfless nature. Your breathing serves not just your individual survival, but the health of the entire planetary ecosystem. Every exhalation feeds the plants that produce the oxygen you need. Every inhalation removes carbon dioxide that might otherwise accumulate to dangerous levels. 2. I/Borisov's journey serves a similar selfless purpose. Its passage through space doesn't benefit the comet itself. It's simply following the laws of physics. But its journey serves the galaxy's ongoing evolution toward greater complexity and interconnection, carrying materials and information between star systems that might otherwise remain isolated. There's something deeply peaceful about recognizing yourself as part of these vast, benevolent cycles. You're not separate from the universe, struggling against it or trying to extract something from it. Instead, you're woven into its very fabric, your existence serving purposes that extend far beyond your individual consciousness, while simultaneously fulfilling your deepest personal needs for meaning and connection. As you breathe slowly and regularly in the gathering darkness, feel yourself settling into harmony with these cosmic rhythms. Each inhalation connects you to the stellar processes that created oxygen through billions of years of stellar evolution. Each exhalation participates in the atmospheric cycles that will support future generations of life on Earth, your contribution rippling forward through time. This is the profound lesson that 2I/Borisov brings to our midnight contemplation. We are all part of something magnificent and ongoing, participants in a universal process of circulation and exchange that operates simultaneously on the scale of heartbeats and the scale of galactic evolution. The same physical laws that govern the motion of interstellar objects through the cosmic dark also govern the flow of blood through your cardiovascular system. The same principles of thermodynamics that cause gases to sublime from 2I/Borisov's surface also regulate the chemical processes happening in every cell of your body at this very moment. But you possess something that 2I/Borisov, for all its cosmic significance, does not: the capacity for awareness, for gratitude, for conscious participation in these sacred cycles. Your ability to contemplate these connections, to feel wonder at the interconnectedness of all things, represents something extraordinary in the universe, matter organized in such a way that it can appreciate its own beauty and complexity. In many spiritual traditions, this recognition of interconnectedness leads to a profound sense of peace and belonging. You are not an accident in an indifferent cosmos, but an integral part of the universe's ongoing journey toward greater beauty and understanding. Your consciousness is one of the ways the cosmos comes to know itself, to appreciate its own magnificent complexity. As sleep draws near like a gentle tide, let yourself rest in the knowledge that you are exactly where you belong. Nestled within the great cycles that connect quantum particles to galaxies, individual breaths to planetary atmospheres, single lifetimes to the eternal dance of matter and energy through space and time. The universe is breathing through you, dreaming through you, coming to know itself through your capacity for wonder and love. Rest now in that knowledge, carried gently into dreams by the same cosmic currents that guide interstellar wanderers through their ancient journeys among the stars. As our journey together moves toward its final phase, let's allow our perspective to expand gently outward, embracing the peaceful immensity of the cosmic scales that 2I/Borisov helps us comprehend. There's something deeply restful about contemplating the vast spaces and slow time that characterize the universe beyond our immediate experience. Picture 2I/Borisov now, months after its discovery, continuing its journey away from our sun. Each day, it travels further into the outer reaches of our solar system, passing beyond the orbit of Saturn, then Uranus, then Neptune. Eventually, it will cross the heliopause, the boundary where our sun's influence gives way to the interstellar medium, and return to the cosmic ocean from which it came. But this departure is not an ending, it's a continuation. 2I/Borisov will spend the next few million years traveling through the space between stars, carrying with it the gravitational memory of its encounter with our solar system. In some distant epoch, it may enter another star system, perhaps one where conscious beings look up at their night sky with the same wonder that fills your heart now. This vast scale of space and time, rather than being overwhelming, offers something deeply comforting: perspective. The anxieties and concerns that occupy our daily lives, while real and important on human scales, exist within a cosmic context of such magnificent stability and patience that they take on a different quality entirely. Our sun, for instance, has been shining steadily for 4.6 billion years and will continue to do so for approximately 5 billion more. During all of human history, the rise and fall of civilizations, the development of language and art and science, all the love and loss and discovery that defines our species, our star has varied in its output by less than 1%. This stellar constancy provides the stable foundation upon which all earthly complexity has been able to develop. The same nuclear processes that warmed 2I/Borisov during its passage through our solar system have been operating continuously since long before life began on Earth, and will continue operating long after our current form of consciousness has evolved into something we cannot yet imagine. The galaxy itself operates on even more majestic scales. Our Milky Way contains over 100 billion stars, each one potentially surrounded by its own family of worlds. The spiral arms where new stars are born sweep through galactic space in cycles lasting hundreds of millions of years. The supermassive black hole at the galaxy's center, with a mass 4 million times that of our Sun, provides the gravitational anchor around which this entire cosmic island slowly rotates. Yet even these galactic scales pale before the true immensity of the observable universe. Our Milky Way is just one galaxy among trillions, scattered through space like islands of light in an ocean of darkness. The most distant galaxies we can observe existed when the universe was young, their light having traveled for over 13 billion years to reach our telescopes. But here's the beautiful paradox: this cosmic immensity doesn't diminish your significance, it amplifies it. In a universe of such vast scales and slow changes, the fact that matter has organized itself into something capable of consciousness, wonder, and love represents an achievement of extraordinary rarity and preciousness. You are a way for the universe to know itself, to experience beauty, to feel the profound connections that link all things across space and time. Your capacity for awareness represents something that may be exceedingly uncommon in the cosmos, a brief flowering of complexity in a universe that tends toward simplicity and equilibrium. 2I/Borisov, for all its cosmic significance, is fundamentally a collection of ice and rock following predictable physical laws. But you are something far more remarkable: organized matter that has somehow transcended its material origins to become capable of contemplating its own existence and place in the cosmic order. As you rest here in the peaceful darkness, surrounded by the quiet sounds of night, you're participating in one of the universe's most extraordinary experiments, the development of consciousness capable of appreciating the beauty and interconnectedness of all existence. The same atoms that form your thinking brain were created in the nuclear furnaces of ancient stars. The same physical laws that govern 2I/Borisov's trajectory through space also govern the electrical patterns that constitute your thoughts and dreams. You are not separate from the cosmos. You are one of its most precious and improbable expressions. In the vast scales of cosmic space and time, your individual life may seem brief and small. But in the development of complexity and consciousness, your existence represents a pinnacle of achievement. Matter awakened to its own beauty, capable of wonder, gratitude, and love. As sleep gently approaches, let yourself rest in the profound peace that comes from understanding your true place in the cosmic order. not as an alien visitor in an indifferent universe, but as a beloved expression of the creative forces that shape galaxies and kindle stars. In the quiet depths of our night journey, let's explore some of the most subtle and almost overlooked aspects of ʻOumuamua/Borisov's story, connections so delicate that scientists nearly missed them entirely, yet so profound that they reshape our understanding of how the universe works. One of these hidden revelations emerged only after months of careful analysis, when researchers began comparing the detailed spectroscopic data from ʻOumuamua/Borisov with observations of comets from the very edge of our own solar system. What they discovered was something both surprising and deeply moving. This visitor from another star was remarkably similar to the most pristine comets from our own outer solar system. This similarity wasn't immediately obvious. It required sophisticated computer modeling to account for the different heating histories and evolutionary paths that comets follow as they age. But when all these factors were considered, a beautiful pattern emerged. ʻOumuamua/Borisov appeared to be composed of the same primordial materials that went into forming our own solar system 4.6 billion years ago. Think about what this means. When the first stars began to die and scatter heavy elements throughout the galaxy, they created vast clouds of enriched gas and dust that would eventually condense into new generations of star systems. ʻOumuamua/Borisov appears to have formed from one such cloud, possibly the same cloud that gave birth to our own sun and planets. In a very real sense, we and this interstellar visitor are siblings, born from the same stellar nursery, shaped by the same cosmic forces. The water ice in ʻOumuamua/Borisov's nucleus is chemically indistinguishable from the water in Earth's oceans. The organic compounds detected in its coma are the same carbon-based molecules that form the foundation of life on our planet. This connection runs even deeper than chemistry. The gravitational processes that ejected ʻOumuamua/Borisov from its birth system are identical to the processes that scattered comets throughout our own outer solar system. In the chaotic early years of planetary formation, gravitational interactions with giant planets flung countless objects into highly elliptical orbits or ejected them entirely into interstellar space. Our own solar system has almost certainly contributed its share of wanderers to the galaxy's population of interstellar objects. Somewhere in the cosmic deep, chunks of ice and rock that once orbited our sun are traveling between the stars, carrying with them the chemical signatures of our cosmic neighborhood. This realization transforms our understanding of solar system formation from a local phenomenon into a galactic process. Every star system participates in a vast network of exchange, receiving visitors from other systems while contributing its own materials to the interstellar medium. The boundaries between individual solar systems are far more porous than we ever imagined. But perhaps the most profound hidden connection lies in the realm of time itself. As ʻOumuamua/Borisov traveled through interstellar space for millions of years, it was essentially frozen in time, preserved in the cold vacuum like an insect in amber. Its surface composition remained almost unchanged from the moment it left its birth system, making it a time capsule that could reveal conditions around other stars. By studying this ancient visitor, we're looking backward through time to see how planetary systems formed in different regions of the galaxy under different conditions. Each interstellar object is like a page from a cosmic library, preserving information about stellar environments that existed millions or billions of years ago. The hidden connections extend to the future as well. The techniques developed to study ʻOumuamua/Borisov are now being refined and improved, preparing us for the next generation of interstellar visitors. Advanced telescopes coming online in the next few years will be able to detect these objects earlier and study them in much greater detail. We're standing at the threshold of a new era in astronomy, interstellar archaeology, the systematic study of objects that originated around other stars. Within your lifetime, we may accumulate observations of dozens or hundreds of such visitors, allowing us to map the chemical diversity of our galactic neighborhood and understand how common the conditions for life might be throughout the Milky Way. There's something deeply poetic about these hidden connections, the way individual objects like 2I/Borisov carry within themselves the stories of entire star systems, the way their brief passages through our solar system connect us to the vast community of worlds that populate our galaxy. As you rest in the peaceful darkness, breathing slowly and deeply, you're participating in your own form of interstellar exchange. The oxygen in your lungs was created in stellar explosions billions of years ago. The carbon in your body was forged in the cores of ancient stars. Every breath connects you to the same cosmic processes that shaped 2I/Borisov and countless other wanderers among the stars. You are not just an observer of these cosmic connections, you are one of their most remarkable expressions, matter organized into consciousness, capable of recognizing and appreciating the profound unity that underlies the apparent diversity of the universe. As our journey together approaches its gentle conclusion, let's contemplate the future that 2I/Borisov has helped to illuminate. A future where humanity's understanding of its place in the cosmos continues to deepen and expand in the most beautiful ways imaginable. The discovery and study of interstellar visitors like 2I/Borisov marks the beginning of what might be called galactic astronomy, the systematic study of our Milky Way as an integrated system where matter, energy, and information flow freely between different star systems. This represents a profound shift in perspective, from viewing individual solar systems as isolated islands to understanding them as interconnected nodes in a vast galactic network. Over the coming decades, as our detection capabilities improve and more interstellar objects are discovered, we'll begin to piece together a comprehensive picture of how different regions of the galaxy have evolved over time. Each visitor will carry chemical clues about the conditions around its birth star, allowing us to map the distribution of elements and compounds throughout our cosmic neighborhood. This galactic perspective has profound implications for our understanding of life's potential in the universe. If the basic building blocks of biology, water, organic compounds, phosphorus, sulfur, are widely distributed through interstellar space via objects like 2I/Borisov, then the ingredients for life may be available wherever planetary systems form. But the implications go far beyond astrobiology. The study of interstellar objects is teaching us that our solar system exists in constant communication with the galaxy around it. We receive visitors carrying information about other star systems, and we undoubtedly send our own materials into interstellar space, contributing our unique chemical signatures to the galactic mix. This recognition of cosmic interconnectedness is beginning to influence how we think about space exploration itself. Rather than viewing interplanetary missions as purely local endeavors, we're starting to understand them as part of humanity's gradual integration into the larger galactic community. Future space missions might be designed specifically to intercept interstellar visitors using advanced propulsion systems to match velocities with these cosmic wanderers and study them up close. Imagine the scientific treasures such missions could reveal. Detailed analyses of materials formed around other stars, perhaps even direct samples that could be returned to Earth for laboratory study. But the most profound implications may be philosophical rather than technological. The study of 2I/Borisov and similar objects is teaching us that separation is largely an illusion, that we live in a universe where everything is connected to everything else through networks of relationship that operate across all scales of space and time. This understanding has the potential to transform not just science, but human consciousness itself. As we come to recognize our deep interconnection with the cosmos, we may develop new forms of wisdom about how to live in harmony with the natural systems that support all life. The same forces that guide interstellar objects through their cosmic journeys also operate within human communities, ecosystems, and individual lives. By studying how the universe organizes itself into increasingly complex and beautiful patterns, we may learn new ways to organize our own societies in alignment with natural principles. Future generations may look back on the discovery of interstellar visitors like ʻOumuamua/Borisov as a turning point in human development. The moment when our species first began to understand itself as part of a galactic civilization that spans thousands of star systems and billions of years of evolutionary time. Your children and grandchildren will grow up knowing that the cosmos is alive with exchange and communication, that consciousness like theirs may exist in countless forms throughout the galaxy, and that every breath they take connects them to the stellar processes that have been shaping the universe for over 13 billion years. This expanding awareness doesn't diminish the importance of local concerns, the health of our planet, the well-being of human communities, the preservation of Earth's magnificent biodiversity. Instead, it provides a cosmic context that makes these concerns even more precious and meaningful. We are not just protecting a random planet orbiting an ordinary star. We are nurturing one of the universe's most extraordinary achievements, a world where matter has organized itself into ecosystems of staggering complexity and beauty, where consciousness has emerged to contemplate its own cosmic origins and destiny. As you drift deeper into peaceful sleep, let yourself feel the profound honor of living during this moment of cosmic awakening, when humanity is first beginning to understand its true place in the vast, interconnected web of relationships that we call the universe. The future that ʻOumuamua/Borisov has revealed is not one of isolation and separation, but of growing connection and expanding awareness. We are part of something magnificent and ongoing, participants in the universe's journey toward greater complexity, beauty, and consciousness. As our 3-hour journey together draws to its gentle close, we arrive at perhaps the most beautiful mystery of all, one that ʻOumuamua/Borisov has helped to illuminate, but not yet solved. A question that will continue to inspire wonder long after you've drifted into peaceful dreams. Here is the mystery. In a universe where matter and energy flow freely between star systems, where the same physical laws operate throughout the cosmos, where the basic ingredients for complexity and life appear to be distributed widely throughout space, why is consciousness apparently so rare? Think about this profound paradox. ʻOumuamua/Borisov has shown us that the universe is magnificently interconnected, that matter circulates between star systems carrying the ingredients for worlds and possibly life itself. Statistical analyses suggest that our galaxy contains hundreds of billions of planets, many of them potentially habitable. The chemistry necessary for biology appears to be common throughout interstellar space, and yet in all our searching, in all our listening to the cosmos with increasingly sensitive instruments, we have found no definitive evidence of other conscious beings among the stars. The galaxy appears to be teeming with worlds, but perhaps sparsely populated with minds capable of contemplating their own existence. This absence, what scientists call the Fermi paradox, becomes even more puzzling when we consider the implications of interstellar objects like ʻOumuamua/Borisov. If matter flows freely between star systems, if the universe is as interconnected as these visitors suggest, then why haven't we detected the signatures of other technological civilizations? Perhaps consciousness is far rarer than we imagine, not because the physical conditions for life are uncommon, but because the specific circumstances that lead to awareness, to the kind of reflective intelligence that can contemplate its own place in the cosmos, require an extraordinary convergence of factors that occurs only very infrequently in the universe. Or perhaps consciousness takes forms so different from our own that we haven't yet learned to recognize its signatures. Maybe intelligence throughout the galaxy operates on time scales or spatial scales that make it nearly invisible to our current methods of detection. There's another possibility, even more beautiful and mysterious. Perhaps consciousness is actually common throughout the universe, but it typically develops in ways that leave only subtle traces, forms of awareness that are content to contemplate and appreciate without the need to transform their environments on scales large enough for us to detect across interstellar distances. 2. ʻOumuamua itself embodies this mystery in a profound way. It carries within its ancient nucleus the potential for life, water, organic compounds, the basic chemistry from which biology might emerge. Yet it has spent millions of years traveling through space as an unconscious wanderer, beautiful but unaware of its own beauty. You, lying here in the quiet darkness, represent something extraordinarily different. You are matter that has somehow awakened to its own nature, atoms organized into a pattern capable of wonder, gratitude, and love. The same carbon and oxygen and hydrogen that makes up ʻOumuamua also makes up your body, but in you, these elements have achieved something that may be exceedingly rare in the cosmos: self-awareness. This rarity, if it is indeed rare, doesn't diminish your significance, it magnifies it beyond measure. You may be one of the universe's most precious achievements, a brief flowering of consciousness in a cosmos that tends toward simplicity and equilibrium. But perhaps the mystery runs even deeper. Perhaps consciousness itself is a force in the universe, like gravity or electromagnetism, and we're only beginning to understand how it operates and influences the evolution of cosmic structures. Perhaps awareness is not just a byproduct of complex chemistry, but an active principle that guides the universe toward ever greater beauty and complexity. The study of interstellar visitors like ʻOumuamua may eventually help us understand this mystery. As we learn more about how matter and information flow through the galaxy, we may discover subtle patterns that reveal the presence of consciousness on scales we haven't yet imagined. Or we may find that consciousness is indeed rare, making each aware being, each human, dreaming under the stars, each moment of wonder and recognition, infinitely precious in the cosmic scheme. Either way, the mystery remains beautiful and inspiring. Whether you are one of countless conscious beings scattered throughout the galaxy, or one of the universe's rarest and most remarkable creations, your capacity for awareness represents something extraordinary in the cosmos. As sleep finally embraces you, carrying you into the realm of dreams where consciousness explores its own infinite possibilities, let yourself rest in the profound mystery of your own existence. You are stardust that has learned to wonder about stars, cosmic matter that has awakened to contemplate the cosmos, a living expression of the universe's ongoing journey toward greater complexity and beauty. The mystery of consciousness may never be fully solved, and perhaps that's exactly as it should be. Some questions are more beautiful for remaining open, continuing to inspire wonder and exploration for as long as aware beings exist to contemplate them. Dream well, fellow traveler in the cosmic deep. You are exactly where you belong, at home in the vast, mysterious, endlessly creative universe that gave birth to stars, to planets, to interstellar wanderers like ʻOumuamua, and most remarkably of all, to the miracle of awareness that allows you to appreciate the profound beauty of it all. Tonight, you've journeyed with me through one of the most profound stories ever told, the tale of ʻOumuamua and what it reveals about our place in the vast, interconnected cosmos. You've discovered that we live in a galaxy where matter and energy flow freely between star systems, where the same ingredients that make life possible on Earth are scattered throughout interstellar space, and where consciousness like yours may be one of the universe's most precious and extraordinary achievements. You've uncovered the hidden connections that link your breathing to the circulation of matter through the galaxy, your thoughts to the same cosmic forces that guide interstellar visitors through their ancient journeys among the stars. You've seen how the study of a single comet from another star system opens up new understanding of time, space, and the fundamental interconnectedness of all existence. Most importantly, you've experienced the profound peace that comes from recognizing your true place in the cosmic order, not as an isolated being on a lonely planet, but as a cherished expression of the universe's creativity, a way for the cosmos to know and appreciate its own magnificent beauty. Next time, we'll explore another cosmic mystery that bridges science and wonder, perhaps the strange story of fast radio bursts from distant galaxies, or the hidden lives of the particles that make up dark matter. Each journey will carry you deeper into peaceful sleep while expanding your connection to the vast, beautiful universe that is your true home. If this journey brought you peace and wonder, subscribe for more cosmic storytelling that transforms scientific discovery into gentle pathways to rest and dreams. Until we meet again among the stars, sleep well, and remember, you are stardust contemplating the cosmos, a living poem written in the language of atoms and starlight. Sweet dreams, cosmic voyager. The universe is dreaming too, and you are one of its most beautiful dreams.